Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0139, is associated with the secondary heated oxygen sensor, HO2S, slow response in the Honda Civic models from 2011 to 2015. This code indicates that the secondary oxygen sensor is taking longer than expected to respond to changes in exhaust gases, which can lead to inefficient engine performance, increased emissions, and potential issues with fuel economy. The secondary HO2S, also referred to as Sensor 2, is crucial for monitoring the efficiency of the catalytic converter by providing feedback to the engine control module, ECM, regarding unburned oxygen in the exhaust. It is typically located downstream of the catalytic converter in the exhaust system. Addressing this code involves several steps, including verifying the problem through diagnostic tools such as the Honda Diagnostic System, HDS, and checking the sensor's operation under specific conditions. The secondary heated oxygen sensor, HO2S, plays a vital role in the vehicle's emissions control system by measuring the level of oxygen in the exhaust gases after they pass through the catalytic converter. This sensor helps the engine control module, ECM, to determine how effectively the catalytic converter is operating and whether it is suitably reducing harmful emissions. Positionally, the secondary HO2S is typically installed in the exhaust system after the catalytic converter, making it essential for assessing the converter's performance. If this sensor is reporting a slow response, it indicates that changes in oxygen levels are not being detected as quickly as expected, suggesting potential issues with the exhaust system or the sensor itself. Addressing this code promptly is crucial for maintaining optimal engine performance and compliance with emissions regulations. Several possible causes can lead to the triggering of DTC P0139. First, the most prominent reason could be a faulty secondary HO2S, which may have degraded over time or due to exposure to heat and corrosive exhaust gases. Additionally, there could be wiring issues, such as frayed wires or insulation breakdown, that may cause a poor connection and lead to slow response times. Furthermore, loose or corroded connectors at the sensor or the engine control module, ECM, can also affect the signals transmitted to the ECM and create a scenario where the secondary HO2S does not function correctly. Each of these components must be thoroughly inspected, as they may contribute to the slow response indicated by the code. When DTC P0139 is present, several symptoms may manifest, indicating underlying issues with the vehicle's emission system. One of the most immediate signs can be an increase in exhaust emissions, as the vehicle may not be adequately monitoring the catalytic converter's performance, and hence failing to control the fuel mixture effectively. This in turn can lead to poor fuel economy, as the engine becomes less efficient. Additionally, the check engine light, CEL, will illuminate on the dashboard, a warning sign that should not be ignored. Drivers may also notice symptoms, such as rough idling or hesitation during acceleration, as the engine struggles to maintain optimal performance due to a faulty secondary HO2S. Addressing these symptoms early can prevent further damage to the vehicle's engine management system. The first step in troubleshooting DTC P0139 is to turn the ignition switch to on without starting the engine. This action powers the electronic systems of the vehicle without engaging the motor. After that, clear the stored DTC using the Honda Diagnostic System, HDS, which resets the engine diagnostics and allows for fresh data collection. Following this, start the engine and hold the engine speed at 3,000 revolutions per minute, RPM, without any load. This step is critical as it ensures that the engine is sufficiently warmed up and functioning at a high speed. It is vital to maintain this speed until the radiator fan activates. which signifies the engine has reached a stable operating temperature. Once the fan engages, allow the engine to idle, further ensuring readiness for the next troubleshooting steps. In this troubleshooting step, you will need to test drive the vehicle under specific conditions to gather more data regarding DTC P0139. Ensure that the engine coolant temperature, ECT sensor, is above 158 degrees Fahrenheit, 70 degrees Celsius, which indicates that the engine is fully warmed up. The vehicle should be driven at a steady speed between 55 to 75 miles per hour, 90 to 120 kilometers per hour for 1 minute. This controlled speed is necessary to create a consistent exhaust flow through the monitor of the secondary HO2S. After maintaining this speed, decelerate with the throttle fully closed for a brief period of 10 seconds, enabling any changes in the exhaust composition to be registered effectively by the sensor. This step allows for an accurate assessment of whether the secondary HO2S is responding adequately to the exhaust changes. After the test drive, the next essential step is to monitor the onboard diagnostics, OBD, status for the DTC P0139, utilizing the Honda Diagnostic System, HDS. This diagnostic tool will offer insights into the current sensor's performance and report whether it indicates a failed or passed condition. If the HDS report shows failed, it confirms that the issue persists, and the next logical procedure is to replace the secondary HO2S sensor too. Conversely, if the HDS indicates passed, it points towards intermittent failure. In this case, proceed by checking for poor connections or loose terminals associated with both the secondary HO2S and the engine control module, ECM. If the status reflects executing, continue to drive the vehicle until the data captures a definitive result. Once the troubleshooting process has progressed through replacement or checks of components, it is critical to perform repair verification for DTC P0139. Begin by turning the ignition switch to lock 0 to ensure the system is safe to work on. Following this, reconnect all previously disconnected connectors associated with the secondary HO2S and ECM, ensuring all links are secure and free from corrosion. Next, turn the ignition switch back to on, and proceed to reset the engine control module, ECM, using the HDS. Resetting the ECM clears its learned data and prepares it for relearning after the component changes. It is essential to follow through with the ECM idle learn procedure, which calibrates the system for optimal performance after any repairs have been made. After resetting the ECM, start the engine once more, making sure to hold the engine speed at 3000 RPM without load until the radiator fan activates. This step is crucial for allowing the ECM to relearn its parameters effectively after any adjustments or component replacements have been made. After the radiator fan comes on, allow the engine to return to idle, and then initiate another test drive following the previously specified conditions. Ensure the engine coolant temperature, ECT, is again above 158 degrees Fahrenheit, 70 degrees Celsius, and maintain a steady speed between 55 to 75 miles per hour, 90 to 120 kilometers per hour for 1 minute, followed by closing the throttle for 10 seconds during deceleration. Once this test drive is complete, monitor the onboard diagnostics, OBD, status again using the HDS to assess if the DTC P0139 has cleared or if further troubleshooting is needed. In the final repair verification step for DTC P0139, it is essential to meticulously check the OBD status results after the recent test drive. You will need to determine whether the HDS presents a passed or failed status. A passed result indicates that the repair process has resolved the issue, signaling that the secondary HO2S is now functioning correctly. Conversely, a failed status will require you to revisit the initial troubleshooting steps to identify and address any lingering issues. In the event that the HDS presents other pending or confirmed DTCs, you should follow the specific troubleshooting protocols associated with those codes, as they may also affect the overall operation of the vehicle's emissions control systems. To prevent issues with the secondary HO2S and potential recurrence of DTC P0139, implementing regular preventive maintenance is fundamental. This includes routine checks of the oxygen sensors to ensure they are free from deposits and operate correctly. Additionally, it's crucial to inspect the associated wiring and connectors for signs of wear, fraying, or corrosion, as these can lead to electrical faults and impact sensor performance. Scheduled emission system service, according to manufacturer recommendations, can also contribute to the longevity and reliability of emission components. By proactively maintaining these aspects of your vehicle, you can minimize the chances of encountering similar diagnostic trouble codes in the future. In conclusion, addressing DTC P0139 promptly through established troubleshooting steps is essential for maintaining the Honda Civic's emission system integrity and overall vehicle performance. The process involves verifying the problem, conducting comprehensive tests with the HDS, and ensuring proper repairs or replacements of components, such as the secondary HO2S. Identifying potential causes, including faulty sensors or wiring issues, plays a crucial role in effective diagnosis. Moreover, regular preventive maintenance and inspections are vital to avoid future occurrences of this DTC. By following these guidelines, vehicle owners can ensure that their Honda Civics operate efficiently and comply with environmental regulations. Please like and subscribe to the channel. See you next time.